Hello everyone, I welcome you all in this C programming and data structures lecture. This is part 2 of application of stacks Infix to Postfix. So without any further delay, let's get started. In this presentation, we will learn the importance of Postfix expression. Before moving on to understand how to write a program to convert an Infix expression to a Postfix expression, we must understand the importance of Postfix expression because it helps us in motivating that why Postfix expressions are required. It is important for us to understand that postfix expressions are better in comparison to infix expressions when it comes to computers. Computers prefer postfix expressions over infix expressions. Why is that so? We will learn this in this presentation. There are two ways to represent an expression. First one is infix notation. Second one is postfix notation. So we have two different notations, infix notation and postfix notation. Actually, there are three ways. There is one more called prefix notation, but for this presentation we will deal with these two notations only. Okay, let's first deal with this notation, infix notation. You can imagine it like some person is trying to fit in between two different people. Okay, so you can understand this, that this person is trying to fit in between. So this is how you can imagine an infix notation, right? Infix, as the name itself suggests. What is an infix expression? It is simple. This operator is trying to fit in between these two operands, right? So you can think of this as an infix notation. The operators are written in between their operands. Okay, so this is what infix expression is all about. This is an infix notation. You can see this a plus b. This operator is in between these two operands. That is why this is an infix notation. Now here is one example, a plus b divided by c. You can see that division operator is in between these two operands and plus operator is in between these two operands. Hence this expression is an infix expression, right? The expression literally means first add a and b, then divide the result by c. First add a and b, then divide the result by c. But this is not always true, right? Although it seems like, okay, we have to evaluate the expression from left to right, but it is not always the case. There is some extra information required by the infix expression. Infix expression always demands for some more information. Now what is that information? Infix expression requires extra information to make the order of evaluation of operators clear. It is very important in case of infix expression to understand the order of evaluation of operators. Not every operator has the same priority. Understand this. It requires the information about precedence and associativity of operators. In simple terms, it requires the information about the priority of operators. Fine. And it also requires the information when the operators have the same precedence, then what to do in that case, right? Obviously, these two things are required by the infix expression. When we try to evaluate an infix expression, it is important to understand the order of evaluation, right? Here is an example. Let's say a plus b divided by c is given to us. We want to evaluate this expression. A normal person who has no idea about how to evaluate an expression will go like this. He or she may first add these two operands, and after this maybe he or she will try to divide the result by c. But we have to understand this, that precedence and associativity of operators come into play in case of infix expressions. The usual rule says that the division must be performed before addition and subtraction. It is very important that the division must be performed before addition and subtraction. Hence, the division will be performed first and then addition in this expression. Fine. We know this usual rule that division must be performed before addition and subtraction. And let's see one more example. Let's say we have this expression a plus b divided by c into d minus e divided by f plus g within parentheses. This is an infix expression, of course. Here, of course, this expression will be evaluated first because parentheses has the highest priority. No matter what is there inside the parentheses, they will be evaluated first. So definitely this expression will be evaluated first. Then definitely this expression will be evaluated because here we have a division operator, we have a multiplication operator, then again we have a division operator. Here I'm assuming that the associativity of these operators is from left to right, which means that first division will be performed, then multiplication, and then this division, of course. So this is how we can evaluate the expressions. The associativity comes into play because these operators have same precedence. Multiplication and division has same precedence. That is why. Okay. So this division will be performed first, and then this multiplication, and then this e divided by f plus g, right? Division of e and f plus g. After this, we know that we are left with plus and minus, that is addition and subtraction. Again, they have same precedence. I'm assuming again that their associativity is from left to right. Hence, this A plus with this result will be evaluated first, and then the subtraction of these two operands. You can treat this as one operand and this as another operand. So you can just subtract these two operands, right? So this is the final result so obtained. You can see the priorities of all the operators and how to evaluate an expression based on the priorities of the operators, right? Now, the above expression requires multiple scans, isn't that so? And every time we have to reach a different place in an expression for evaluation, definitely. You can see this over here that every time we have to scan this expression from left to right. Okay, let's go from left to right and scan this expression. Okay, we have found that f plus g has the highest priority. Then we have found that b divided by c has the second highest priority, and so on. The above expression requires multiple scans, and every time we have to reach a different place, right? Here you can see in scan 1, we have found that an expression between parentheses has the highest priority, isn't that so? So it will be evaluated first. Later on, after performing scan 2, we have encountered that b divided by c, that is this expression, has the second highest priority. In the third scan, we have found out that the result of b divided by c and d must be multiplied, right? So in this way, we got this idea that it is important to perform multiple scans in case of infix expression. Always. This is always true. We have to understand the precedence and associativity of operators, right? We don't know that which operator will be evaluated first. That's why multiple scans are required. Okay, I'm talking about the computers. Humans can understand these expressions properly and they can manually perform all the operations. But when we provide this expression to the computer and we want this expression to be evaluated by the computer will take a lot of time to do this because multiple scans are required, right? So the conclusion is it is inefficient for a computer. Of course, performing multiple scans is obviously an inefficient solution, right? It is a brute force method. You can imagine this. It is a brute force approach and it is not good. Conclusion is very simple. Infix notation requires multiple scans and is therefore inefficient in terms of time consumption. There's no doubt about this, right? Infix notation requires multiple scans and therefore it is inefficient. I was literally thinking about this, that my life would be very easy if there is some notation which doesn't require multiple scans. Seriously, my life would be very, very easy, right? And of course, the life of my computer as well. So we have learned this already, that there are two ways to represent an expression. First is infix notation and the second one is postfix notation. We are done with infix notation, right? Now let's deal with postfix notation. I seriously want to make my life easier, right? So postfix notation is actually a solution to this problem. This lady is saying, I'm coming after you. So you can imagine a postfix notation like someone is saying, okay, I'm coming after you. So this means someone is coming after someone, right? So it is important to understand that postfix means coming after. So what is a postfix notation? The notation is simple, A, B plus. The plus operator is coming after these two operands, right? So this is how it should be, right? A, B plus. These are the two operands and the operator must come after these two operands. Now this is a weird looking expression, of course, but later on you will understand this, that this notation is good for computers. The operators are written after their operands. You can see this. This operator is written after their operands. That is why this is a postfix notation. Now here is one example, A, B, C, divide and plus. This is an expression A, B, C, divide, plus. This is an equivalent postfix expression of the infix expression you have seen already in this presentation. That is the expression A plus B divided by C. That expression is actually converted to this expression. This expression is an equivalent postfix expression of that expression. Okay. The order of evaluation of operators is left to right with no brackets in the expression to change the order. You can see there are no brackets involved and the order of evaluation of operators is left to right. Okay. And in the example, division comes before addition. And therefore the division must be performed before addition. You can see this over here that division comes before addition. And as we are scanning this whole expression from left to right, so definitely we will encounter division first before addition. So it will be evaluated first. Hence it is making sense, right? So this postfix expression is actually making sense. Here division will be performed before addition. So already the priority is set. There is no need of any additional information. There is nothing required apart from this. We just need one scan from left to right in order to evaluate this expression. It is very simple. When the computer tries to scan this whole expression, then first it encounters this division symbol, which simply means that the division has to be performed first, right? Now it is making sense. Let's understand the difference between infix notation and postfix notation, okay? And this can be done with the help of an example. This is an infix expression and we will try to convert this to its equivalent postfix expression. It is very simple. Here, we know that this expression has to be evaluated first. So let's just convert this expression first to its equivalent postfix form. Here this is f plus g, right? This becomes fg plus. We just have to move our operator towards right. Okay? F plus g becomes fg plus. And this will be treated as one operand. Of course, this will be treated as one single operand. Okay, remember this. After this, we have to evaluate this expression. That is b divided by c. Here, of course, this becomes bc divide. bc and this divide symbol. This will be treated as one operand. Then we have to evaluate this expression, right? bc divide multiplied by d. Please treat this as one single operand and this as another operand. So here we have two operands and we have a multiplication operator between these two operands. So definitely this multiplication operator moves towards right and this becomes bc divide d star, right? Now I hope you got the idea, right? Then after this, the next expression must be e divided by fg plus. Treat this as one operand and this is one more operand. We have two operands and a division operator in between these two operands. We have to move this operator towards right. Isn't that so? This becomes EFG plus divide. Then after this, we have to evaluate this expression. This becomes ABC divide D star plus, right? And finally, we have to evaluate this whole expression. This is one operand and this is second operand. And we have minus in between these two operands. So we just have to move this minus towards right. And that's it. This is the equivalent postfix expression. ABC divided by D star plus EFG plus divide minus. A weird looking expression. Isn't that so? So this is the difference between an infix expression and a postfix expression. And I hope it is clear to you that how to convert an infix expression to its equivalent postfix form. It is simple. We can do this manually. There is no problem in doing that. And it is not difficult to understand that this postfix expression requires one scan. Just one scan. Okay, you can see this over here that plus comes before division. Why is that so? Because here f plus g will be performed first because of these parentheses. Isn't that so? And you can see this over here, no parentheses are required. Here we have fg plus. This will be evaluated first. The addition will be performed before division. So it is making sense, right? This postfix expression is making sense. This addition will be performed before this division. Hence, you can see this that postfix expression is not very bad. It is not good for humans, of course, right? Postfix notation doesn't require multiple scans. A single scan is required and it's therefore efficient in terms of time consumption. There's no doubt about this. It just requires a single scan, right? Hence, we can conclude that this expression is good for humans while this expression is good for computers. Simple. I hope the whole idea of infix notation and postfix notation is clear to you. We are done with infix notation and postfix notation for this lecture. Okay friends, this is it for now. Thank you for watching this presentation.